everybody. Ivan Novick here. Sound check. Let's see. This is my first time using the YouTube streaming. So there's going to be some AV check and some testing. So you can see here, you can see the natural background. I haven't learned how to create a fake background in YouTube streaming. And I'll have a bit more to say about what we're going to be doing with the streaming and with providing some updates here on a consistent basis on YouTube. And I'm just looking around here to see how this works. So today what we're going to do is we're going to get through some AV checks, make sure that we can access the system, we can talk, and I can see comments, etc. And then we're going to be, I have some material here on the latest info regarding Greenplum, which I'm going to go through on a casual basis here and try and see if we can get other people to join in and provide some questions, and we can do some Q&A. So bear with me here. Let's see. Right. Well, we're going to give it a go, and we'll see how this works, and we'll improve it next time if it's not perfect. So some housekeeping items to get started. Let's see here. What I want to do, read some housekeeping items to you. This presentation, okay, let's see here. All software releases are on an if and when available basis and are subject to change. This information is provided without warranty of any kind, express or implied. It's not a commitment to deliver any material, code, or functionality. All purchasing decisions regarding software should be made based on the currently available features, and any release or timing of any new features or functionality described in this presentation may fully and totally change. So just get that out of the way. All right. So I see there are some folks on the streaming. It would be great if somebody on the streaming could go and throw a chat in the chat message just to wake that channel up and I could see some interaction. But in any case, we will get started. So starting with, I want to give a happy birthday announcement to Greenplum version 6. So Greenplum version 6 released in September of 2019. We're now in October 2020. And as I've learned in my career, I always would love to celebrate releases 1 year after they're done. That's when you really know, that it's worth celebrating. And we've been getting really good feedback on Greenplum 6. Quite a few major installations, people upgrading from Greenplum 4.3 to Greenplum 6, and feedback in the order of things like, this is the best release ever. Is this, users asking, is it running on empty tables or is it really running on the data? And then checking and saying, oh yeah, it's working correctly. Can't believe how fast it's running. So really, and from a quality point of view, this is rock solid. As this is I want to also give a quick warning. This is an infotainment session, so it's meant to be slightly entertaining as well, not just informative. Few stories I wanted to share with you. One is, it's always great to hear from the new generation terminology, movies and things that you've never heard of and be introduced to them. So I was introduced to a terminology called something called the GOAT. Now, I don't know if you all know what the GOAT means in popular culture, but it means apparently the greatest of all time. So I would say at this point, Greenplum 6.11.1 is the GOAT. It's the greatest Greenplum of all time. It is the most rock solid stable. It is the most performant, most feature rich. And that journey started a long time ago. I mean, I can remember back in 2015 when a bunch of folks descended into London, and we had a few-day seminar asking ourselves, hey, Greenplum is based on Postgres version 8.2, and as a strategy, our goal is to be an MPP data warehouse analytical platform based on Postgres. How can we feasibly move from Postgres 8.2 to a modern or recent version? And that started back in 2015. And when we were open sourcing Greenplum, and it took a long journey that we've been on here. And now to see 1 year after the Greenplum 6 release and to see the feedback and some of the things that kicked off in people's minds back in 2015 being used in production in 2020, and really seeing the benefits now on global scale data warehouse systems that have thousands of users and millions of queries running at scale and running 24/7 operations with extreme performance. It's really, so happy birthday to Greenplum 6. 1 year, happy birthday, and many more anniversaries. And today we'll also give a little sneak peek as well into Greenplum 7 and what we're thinking about there. But while we're still on the topic of, hey, what's new, what's going on in Greenplum, and again, a quick ask, anybody on the live stream, if you could throw a message in the chat. Nobody's throwing a message in there. It'd be great to figure out how the system works. By the way, I did a little research and found another platform that can be used for live streaming. It has a lot more features. It still goes to YouTube, but it allows for multiple co-hosts and screen sharing and things like that. So I'm going to give that a try as well in the near future. We can see how that goes. In any case, checking here from my notes, since we're not doing screen share. So another key point on the achievement of Greenplum 6 is really the diverse workloads. So there's a big argument, I would say, in the academic community, you can research this, about is it better to have one database that's general purpose and that can handle all kinds of diverse workloads? Or is the world moving towards a world where you've got all these specialized database platforms that do very individualized kind of workloads, and then you deploy a spectrum of these 10 databases? Hey, Craig, what's up? Thanks for the message. It's awesome. Hey, Brian, thanks for the message. It's really great. Now we got some interaction here on this streaming. Happy Friday from Europe and from the East Coast, getting these messages. So thanks for that. So anyway, back to the perennial debate of one big database versus all these specialized databases that have specialized use cases. And they're both sides of the argument. There's academic folks writing that you'll never be able to get the performance with a general purpose DB that you can get with a special purpose, and other people saying the cost of operations of having 10 technologies and 10 DBA teams and whatnot is overwhelming, and that people will consolidate to one platform that works pretty well for as many workloads as possible. And if you look out in the world and you say, let's look at the evidence, who's been successful in the database world? Well, let's look at, who's the most famous database company out there. Okay, I think I can say it without getting sued, right? So Oracle is a big famous database. Is it a specialized database? No, not really. It's a general purpose database. It just kind of works, right? And I think when we look at Greenplum and we look at the MPP, the question is, the feedback we've been getting over the last decade is okay, we're using you guys for data warehousing, for advanced analytics. And once you become into production, now the expectations of the users change, is that they see this big database supporting 50 terabytes or 100 terabytes or a petabyte or more data. And they're asking the question like, Hey Ashwin, what's up? By the way, good morning in Sunnyvale. So they're asking the question like, now that I've got this system live, like I need to do all kinds of normal database operations. I don't want to have like another database to ask like query number 17 and another database to query 18. So one by one, people keep asking for all of the features of a database. And when you look at Greenplum 6, you can see that we really have broadened the scope. So we have achieved something like 10,000 or 30,000 single row updates per second based on indexes, right? That's traditionally known as an OLTP workload to do updates, right? Single row updates, but we're able to do tens of thousands of updates a second on Greenplum 6. And that's just one example. We're also able to go to the other spectrum and say, hey, complex many table joins where you need the ultimate query optimizer that knows how to do join order and has a whole series of algorithms to search through the infinite space of query plans when you have a subquery and you have correlation and you have 8 tables or 50 tables or 20 tables, and you need to determine the proper join order. You need to determine on an MPP whether it's broadcast or distribute or to distribute the query. So all these things. So we're talking about anything from the super complex query to the traditional group bys and aggregations and sorting to the short queries where you're doing single row lookups and updates, and then even down to things like machine learning, things like geospatial, things like graphs. So really the goal for us with Greenplum 6 is to have this robust database that just works. And it just works on 50 terabytes, and it just works on 500 terabytes, and it just works on 5 petabytes, right? And so I think we're well on our way there with Greenplum 6 and getting great feedback. By the way, if there's anyone out there, I see there's now double digits folks on the chat. This is also a fully open to interruption, disruption. Throw in, if you have any Q&A, if you're a new user, a newbie, or anything like that, throw in your chat. We also have some experts on the line that can answer the questions if I don't see it or get to it. Another thing that's in the what's new category, definitely want to point out to you folks, is resource groups and workload manager. So now that you've got this huge database and this huge, let's say you've got 10,000 users that want to access the data, and you've got, let's say, I don't know, 500 terabytes of data, and you've got people from, let's say, 20 departments in your business, and they all want to access the same system. So how are they going to do it, right? And how is the administrator going to create order to make sure people's needs are met and SLAs are met? So the resource groups, which is the superseding technology from Greenplum's resource queues, it uses the underlying C group technology and provides swim lanes where you can allocate specified amount of resources, memory, CPU, etc., and make sure that the people who need the resources get the resources in an orderly fashion. And that framework lays the key foundation for multi-user resource scheduling. Now, for the folks out there who are longtime Greenplum users but maybe busy on their day job, it's important to recognize all the parameters have changed. When you switch over from resource queues to resource groups, it's really important to read the manual and see what the new parameters are. You might be used to setting vmem protect limits in resource queues. That's an irrelevant parameter in resource groups, so definitely don't care what the vmem protect is, right? You just set percentages of how much memory, and it's important to read the manual and set up your resource groups correctly. But then with the workload manager, what we're bringing is the dynamic. So you can go in there, you can look at a slow query or a really CPU hog query. You can click on it and say, hey, move that query to a high CPU workload. Let's say I created a resource group for CEO that's got some dedicated resources. I can click on the query manually and move it to either a penalty group or to a high CPU group, and then you can change it on the fly. It'll just adjust dynamically and start processing. The other thing you can do is you can set up rules, right? So looking at the rule capability, you go into the command center, and you can set up things like based on the cost of the query, the planner cost, based on how long it's been running, based on the CPU that it's using or the slice count. You could set up rules. You can either automatically terminate the query. You can log the query to the GP metrics table so that you can just see, hey, it violated the rule, and you can come back and study that. Or you can switch it to the another resource group on the fly. So you can say, hey, I've got a penalty box query, anything, penalty box group, anything in that query, anything in that meets these parameters, it's taking up too much resources or it's taking too long, move it to the penalty box, slow it down, let everybody else continue. Or terminate it, whatever you want to do. So that is on the resource groups. Now, this is an infotainment session, so I wanted to test and see if I can play Spotify music and if you can hear it here. If there's anybody still on the line, please, can you confirm me if this is an audible music? No music. I need a new technology then. All right, we're gonna get a new streaming platform for next time. Still YouTube, but we need some smarts in that. Okay, I had some great music going, but I won't ruin the surprise of what it was. All right, with that musical ramp, let's transition here to the fact of what's coming in, what we're going to be working on for Greenplum 7. So let's see. Continuing on some of the same themes, one of the key themes is the Postgres integration and the Postgres merge project, as we call it. And so if you're following the open source development list, you will notice that our development branch for Greenplum 7 is already now based on Postgres version 12. So that includes everything from starting from Postgres 9.5, 9.6, 9.5, 9.6, 10, 11, and 12. All of those versions are integrated. So what that means is that our development team goes and takes that code, brings it in and merges it and has to review all of the changes and then see that it safely integrates and look for the optimization opportunities and really integrate it in to the MPP system. So if you go and build your own code on GitHub from Greenplum, you'll see a Postgres 12 base, and there's quite a few interesting features there. My expectation is that our team will be able to achieve new heights as far as performance. Some of the questions about how to do that, I'm going to talk about some of the key interesting things. One interesting thing is something called BRIN index, which stands for block range index. Now, the interesting facts about BRIN index, and again, I'm going to do this without screen share, so I'm just going off my memory here. But some of the problems that you face first of all, why use an index? Indexes are there to help you find what you're looking for in a query directly without processing all the data, right? And historically, and even today, there are public companies who build data warehouses that have multi-billion-dollar market caps and don't have indexes. Why? I don't know. But indexes have been around since probably 1950 or 1970, somewhere in there, and they are important data structures in a relational database system that allows the optimizer to determine dynamically, is it more efficient to scan all the data or go directly to the data that's being requested? That's really important. And in today's Greenplum 6, there's a lot of users who use B-tree indexes, very traditional B-tree index, and they use that for things like searching for a specific record. So you could say, hey, I'm I'm a global shipping company or a national shipping company, and someone's looking for information on a tracking ID. Select all the information where the tracking ID equals XYZ. Boom, you go directly through the index there and it returns in milliseconds, as opposed to scanning and comparing and scanning and comparing, which would be extremely radically inefficient. So that's cool. So you've got the opportunity to create these B-tree indexes, but now why is B-tree not the magic bullet for everything? Well, there's a few disadvantages to B-tree. One is it takes up its own space on disk. So in addition to storing the data, you need to store an index. And the B-tree data structure in practice, when you go and look at it, it can be bigger than the data. So you could have 100 terabytes of data, and then you want to have an index on it. It could be 200 terabytes for the index. So that's one disadvantage. Now you're still going to get that fast lookup, but it's going to take up that extra space. So that's one problem. Another problem is once that index is in place, if you try to continually load more data, so you've got these tracking IDs, or let's take a different example instead of tracking IDs. Let's say we're running a stock market and we've got trades. So every trade, you've got how many trades happening per second, right? Hundreds of thousands or tens of thousands of trades per second. Each one might have a trade ID. And then someone wants to go and search for that trade, and they do a query, and the index will help you get directly to that trade through terabytes and terabytes of data. But the problem is the trades keep coming. So when do you create the index? You can't wait and create the index later, right? You need to be creating the index. The index needs to be in place, and you need to be loading the trades. The problem is that loading data into the B tree is a whole bunch of distracted, I don't want to use a technical term like random, but it's a whole bunch of IO operations which are expensive, and it turns out that this could slow down your loading by an order of magnitude or something like 10x. So you don't want that, right? And so a lot of people have to then do gymnastics to, hey, let's create index on old data, the new data as it's being loaded, we won't have an index, we'll do sequential scan, and then we'll come back and we'll put an index later. So that's a problem. So that's what I'm pointing out is the second kind of problem with B trees, which is that loading with the B tree in place will make it something like 10x slower. So that's a problem. So bring in now the new kid on the block, which is the block range index, BRIN index, and it has characteristics which solve these two problems. It has the ability to, the space on disk is going to be a small fraction of the data. So that problem is solved. And secondly, the loading speed will be still slower than with no index, but dramatically faster than a B tree. So you can have this BRIN index on, continue to load, and not experience nearly as much of a penalty in terms of loading. And depending on what kind of query you ask, it can still save a tremendous amount of IO and make the queries dramatically faster, or in some cases equal to a B tree. I don't want to promise in all cases because it is fundamentally different what a BRIN index does than a B tree. So you're going to have to look at it and study that and see, hey, is this a good use case for a block range index or not? But it's another tool, and I think it'll be widely used. It has been widely used in a number of popular systems. I'm not going to name the brand names, but they do have BRIN index in or equivalent to BRIN indexes in quite a few other databases, and that's an important new thing that's going to help a lot. And that's a feature that Postgres has, and looking forward to seeing that it's actually available in open source if you build your own Greenplum right now. So I think I'll just maybe touch on one more feature and another ask. If anyone has any questions out in the chat, feel free to add the questions. There's a lot of stuff going on for 7. I'm not going to go through everything and use up all the content for the future. Today we talked about the BRIN index. One more thing I want to talk about today is, let's see which one I want to pick. Compiled queries, or just-in-time compilation, also known as JIT. JIT, just-in-time compilation. So what is this? So just-in-time compilation means that if you think about it, SQL is a programming language. And if you study in computer science, it's an interpreted program language. It's not actually, you don't run SQL when you write the SQL through a compiler. You don't write your SQL, compile it, and get a binary, and then go run your query. What you do is you run SQL, you throw it out dynamically to Greenplum or any database, and then on the fly, Greenplum will convert that into an execution plan and execute it, right? Now, compare that to writing code in C++. When you write code in C++, you write the code, you compile it, then you get a new file, that's the binary file, and then you run that. That code is going to be optimized by the compiler. So what we're talking about here is when that SQL comes in to the database, then on the coordinator node or the dispatcher node, the node that receives the query, one thing that it's going to do is a new additional step, which is it's going to run it literally through a compiler, and it's going to produce optimized machine code specifically for the query that you executed. So it's not going to literally run the database binary software. It's going to generate new binary software that runs to execute your query for every query that's executed. Now, that could take, I don't know, 10 milliseconds or some number of milliseconds. So it can't be used universally, because if you're running really short single row lookups, you don't want to be doing that every time. But imagine you're running a big processing. Sure, you'd spend 10 milliseconds to optimize it before you execute it. And there's going to be a number of parameters and gucks to control that. And what you end up getting is, in benchmarking we've seen that take a traditional TPC query, something like TPCH query 1. In development circles, that's a famous query because it's a very basic group by aggregation select query, if I recall, and does some very common actions that anybody who's doing basic reporting or analytics on a data set would do. And by running query 1, which is hey, select from these, let's say, trades or orders or whatever they are, and do group by and aggregation and the basics of SQL, essentially of OLAP. What you do is you can see that by running it through the just-in-time compilation, the runtime actually gets twice as fast. And that's just on the iteration that we have right now. There's still room for improvement, but the fact that you can actually pre-process the thing and now the workload's running in double the speed, those kinds of optimizations don't come around every day. And so being able to inject this capability into Greenplum 7 and let it loose on your huge workloads and seeing what will happen when you dynamically compile these queries into faster runtime executables, it should be quite interesting. And it's going to be, when we start adding in all these pieces, I think that when we finally get to Greenplum 7, people are going to have that new car experience where you get that new car and you say, oh my God, I should have gotten a new car a long time ago. It is so smooth and fast, right? And I think that's what people are going to get. So anybody out there have any Q&As? And I can't play any more music. I didn't prepare any jokes. Okay, let's see. Current thinking on AutoMaster failover for GP7. Okay, thanks, Craig. So in the vein of it just works and having a database that just can meet 90% of your expectations for use cases at large data sets, one of the really important features in my mind is to take our master failover to the next level of automation. So we have a redundant Okay, originally called master node. It's going to be renamed. I believe the new name will be called the coordinator node, which is a more accurate kind of description for it. But in any case, the single point of entry where the queries come, and we have currently in Greenplum high availability. That if that machine fails or that VM fails, you can start it up on a new machine and you won't lose anything. Come right up. It's very rare occurrence and whatnot. But what we need is a system that can dynamically shift between multiple coordinator master nodes on the fly, and that's something that I'm seeing a lot of progress. And I believe, remember the disclaimer from the beginning that you should buy the product based on what's there. There's no promises, but I expect to see that we can do AutoMaster failover in Greenplum 7. And I'd like to see our developers and engineers be thinking about how the secondary master node could be used for, or controller. Thanks, Ashwin. The new name is controller. Thanks so much. So there's going to be a primary controller, and I'd love to be able to see that the secondary controller could also accept read-only queries, right? So that we could start scaling out to more concurrent sessions and support, let's say you want to support an entire company's worth of analysts. Let's say you want to have 100,000 users all hitting the database. So having that secondary master, and if you look at Postgres technology, Postgres already has a replication system, which we use for the controller, but it also has the hot standby capability, the ability to query the secondary node, right? The one that's getting the replication. And it even has the ability to have multiple replicas. So you can have the coordinator and you could have 10 replicas in Postgres, right? And all of them could be doing read-only queries with the primary controller being the place where writes go to. And then things like pSQL and libpq and the client programs can be configured to automatically talk to whichever is the active nodes. So really what we're talking about is being able to scale out. It's really important to be able to scale out concurrency to essentially to unlimited levels when it talks to short queries, right? That don't take up much resource on the back end, but that take up resource on the front end. And so I think, this is a really important focus. And I'd expect to see improvement in this area in Greenplum 7, starting with the automation of the failover of the coordinator, and then leading towards additional features like the hot standby, the multiple hot standbys down the road as we can get that, as we can engineer that. And then another question here. So let's see. Hey, sorry for the pronunciation. From me, this is Shanmuga. Somebody I don't know before. So how is HTAP optimizations coming into Greenplum to handle both transactional and analytical? Okay, great. So Greenplum 6, the one on the shelf that can be downloaded today, supports pretty high performance transactions. It can support, oh, okay, hey, thanks. So you go by Priyan. Nice to meet you. Greenplum 6 can already support pretty high volume transactions, right? So if you're looking at wanting to do 10,000 updates a second in an ACID, right? Atomic, consistent, isolation, durable, basically guaranteed delivery of transactions, and you want to do 10,000 updates a second with 100 parallel users, you can do that now, right? To me, that's transactional. Now, true, if you look at a native Oracle system and look at its capabilities around OLTP or transactional use cases, they've been doing that for years. Greenplum really has started and is used primarily for analytical workloads. So there's a whole lot of intangibles that you need to think about when building a transactional database. And that's a journey that we're on in bringing in those capabilities. But if you just look at the raw understanding of what is a transaction, you're basically, as they say in the textbook, to remove money from account 1, deposit to account 2. And if there's any issue in the middle, don't complete it until it's all done 100% safely, so that it's been an atomic, consistent transaction, right? We support that. We support that now, right? And we can support that in the order of magnitude of thousands per second, right? With indexes, and that's available today. So if you have, a very heavy analytical workload, very heavy reporting workload, and you want to integrate transactions into that same system, we're one of the only systems that can do that today, right? And we're going to keep pushing that edge. So thanks for the question, Priyank. All right, so again, time for me to play the music I can't play. Have a happy Friday. I am going to try and get multi-user hosting going so that I can have a co-host next time I do this and bring in some new updates. Have a great Friday. Enjoy working on and using Greenplum, and see you next time. Bye, guys.